Good morning, everyone, or good afternoon. It's been a long day already. My name is Dominic Preuss. I'm the product lead for storage and databases on the Google Cloud Platform. Very excited to speak to you guys today about how to scale your ideas from concepts to petabyte. The goal of this talk is really to give you an overview of our storage offerings and our databases, and to give you a set of reference architectures that you can use when you're considering how to build your applications. These are not prescriptive. These are just some things to give you an idea of how people are structuring these things so that when you are getting ready to bring your applications to Google Cloud, you've got a starting point. I want to start by talking about the Google Data Platform. So when we talk about the data platform, we really think of it in a very holistic way. We don't think about individual products or silos of data. The idea here is that we have an integrated, no-ops cloud data platform that allows you to build your applications. And most importantly, it's about you bringing your data to the Google Cloud Platform in the way that makes sense for you, and then us making sure that we offer you tools that allow you to move, transform, and derive value from your data, regardless of where it is in the platform. A very good example of this is making sure, we've talked a lot about machine learning, where are you going to store your training data? And all of that information has to be in the platform somewhere. And so how do you go about doing that? So as a level set, let's talk about the portfolio of storage offerings and databases. First of all, the one that most people know about is Google Cloud Storage. So this is our object storage system. It's designed for both structured and unstructured data. And we use it, people use it obviously for serving static content, like images and video. But it's also used for archival backups as an intermediate data location for data processing jobs. Once we get into the databases, our oldest offering, original offering, or one of our earliest offerings is Cloud SQL. So if you need a managed MySQL solution, again, no ops, you spin up an instance and you have a database, Cloud SQL is the solution for you. This is really useful if you're using a web framework or some existing application that requires MySQL or some other off-the-shelf RDBMS. And by RDBMS, I mean Relational Database Management System. If you want a NoSQL solution and want to go down that path, we offer two solutions. One is Cloud Datastore. Cloud Datastore really serves the document store use case in our platform. So it's great for mobile applications, web applications. If you have a lot of JSON data, this is a great place where you can basically start from scratch and scale up your application. The other NoSQL application that is our newest is Cloud Bigtable. It's currently in beta. This is a wide column store that provides a H-based client compatibility for you to build your analytics applications. This is really great for time series data, metrics data, things like advertising technology, financial services, and Internet of Things. If you get a chance tomorrow to attend the talk by FIS about Bigtable, I highly encourage it. Really compelling use case that they've been able to use it for. And the last one is cache. So if you need an in-memory key value store, App Engine Memcache is our solution to allow you to put a caching layer in front of your application. Commonly, this is used in web, mobile, and gaming applications. Great. So how do I get started? So if you have an idea and you want to prototype it or build something that you can share, how would I do that? So the simplest architecture that you can put together is a set of clients. And this just might be yourself or one or two friends. If you go down, generally we see our developers split into two different use cases. Either they feel very familiar with MySQL and relational databases, or they want to develop NoSQL solutions. And so I'm going to talk about both use cases so that we can talk about those as architectures. We'll start with NoSQL. So the simplest thing you can do is spin up an App Engine application and store your application data in Datastore and your static data in cloud storage. And so this should allow you with almost no configuration to get up and running, storing data that you can share it back to a web application or a mobile application just as a prototype. Now, if you wanted to go down the relational database path, the way that you do this is you would spin up Compute Engine to use whatever framework you want. Now, this could be Node, and we just introduced Node and App Engine. This could be Python Django if you're a Python developer. It could be WordPress that you're running on a Compute Engine instance. And then you would, again, set up a Cloud SQL, so you actually have to think a little bit. You have to set up an instance, pick a size, and tell us how much storage you want. And then you would use cloud storage just like you would with the other solution to store your static content. So this can literally go from 0 to serving applications in an hour. Right? This is the simplest way that you can get up and running on Google Cloud and start serving data. Now, if you take that concept and you're like, oh, this is interesting, and I want to scale it out and start to move it to production and share it with more than just me and a couple friends, you have to start getting more complicated architectures. If you're going down the MySQL path, good news is App Engine and Datastore will just scale for you. You don't have to make any changes. You just send it more traffic, store more data, and it'll scale for you. Same thing for cloud storage. These are fully managed, leave it and forget it type applications that allow you to scale up. So your architecture is very similar for the NoSQL path. If you're going down the relational database path and you need to scale, and let's just assume you have more traffic that you can put through a single VM, you would put a Google Cloud Load Balancer. There's a couple of talks that have happened today about this, in front of several VMs running WordPress, Django, Node, Rails, whatever framework you happen to be running. And then speaking back to Cloud SQL. Now, with Cloud SQL, when you set it up, if you are running in a production environment, you add a failover instance. And that failover instance gives you high availability. So again, in a fully managed way, we'll give you a multi-instance MySQL cluster, a set of replicas that handle failover. And if for some reason there's an issue with your primary Cloud SQL instance, we will fail over to the failover replica so that you'll have no downtime. This is all done with a couple of clicks when you set up your MySQL instance. Again, cloud storage for all your static content, really the bedrock of all of these architectures for your static content. Great. So now I've gotten up to 1 gigabyte of data. I've got a bunch of data in my system. And what am I going to do now? So if you are continuing to go down the RDBMS path, if you've got MySQL running, you now have lots of websites and lots of apps all talking to your application. So one thing, again, Cloud Load Balancer. And you could do this with HA Proxy or whatever your favorite load balancer is. But if you're in the managed world where you want Google to manage it for you and take advantage of our amazing site reliability engineering organization, then you would use the Cloud Load Balancer to put in front of your VMs, again, to shard your request traffic to the various compute pieces, and then go down to the Cloud SQL level. Now, Cloud SQL, it starts to get more interesting. Once you get above the amount of traffic that you can put through a single VM, then you have to start thinking about how to shard your traffic. And this is where MySQL starts. You have to take advantage of some more advanced MySQL features. So in this case, what you want to do is have your Cloud SQL instance, and you'd want to add some read replicas. So Cloud SQL offers you the ability to add as many read replicas as you want for your master instance. And then at the application layer, you would want to shard your write traffic and your read traffic. So all of your write traffic would go to your master node. So you could scale up to the max number of requests, max number of write operations that you can put through a single GCE VM, which is what Cloud SQL 2nd generation uses under the hood, and then add read replicas to meet the amount of read traffic that you have. So this basically gives you a certain level of horizontal scalability to split your write workloads and your read workloads. Again, all of this is fully managed for you. If something happens to your read replica, Google site reliability engineers will fix it. If something happens to your master instance, then we will take your failover instance, set it up to be read-write, and then move the IP address over so that you'll have the minimum amount of downtime. You don't have to do anything. This all happens for you automatically. It's all part of the managed service that Google offers for Google Cloud Storage. Some interesting things about Cloud SQL 2nd generation. We released it in December of last year. It's currently in beta. It is our fully managed MySQL service. It's 3.5 nines of availability. And one of the things we just released that we're very excited about is hot grow. So what's great about this is, in the situation where you've gone from 1 gigabyte to 1 terabyte, let's say that you only specified 2 gigabytes of storage for your MySQL instance. Now, if you were rolling your own instance and wanted to increase the amount of disk, you'd have to create a new instance, or shut down your instance, create a snapshot of your persistent disk volume, bring up a new PD volume with that snapshot, reattach it to the VM, and then you could continue going. But that obviously requires a lot of work and actually creates some downtime. With HotGrow on Cloud SQL, you can literally go from 10 gigabytes to 100 gigabytes to a terabyte, all the way up to 10 terabytes with no downtime on the VM. So you can dynamically increase the amount of capacity that you need for Cloud SQL and for your MySQL instance without having any downtime. So we're doing the best that we can to keep you from having to make any decisions up front, and allowing you the flexibility to increase your capacity to meet whatever load that you have. So now NoSQL. So if you're going down the NoSQL path, again, the architecture looks remarkably similar. You've got a number of websites, mobile applications speaking to your App Engine app, and then you're storing all of your data in Datastore. Now, some things that you should think about in Datastore, once you're starting to get above a gigabyte of data and you're starting to get to more meaningful amounts of data, Datastore offers you a number of features that helps with your performance and allows you to tune. So things like setting up composite indexes and doing other maintenance things that you can do to look at, do I need indexes? What does my traffic look like? What is the performance of my traffic? What kind of characteristics am I seeing? And starting to use some of the more advanced features of Datastore to tweak the application to get better performance out of it. Again, the beautiful thing about Datastore is you don't have to choose anything ahead of time. You don't have to say, I'm planning, this application is going to go viral and I need a terabyte of data. You just say, I need a place to store some data. You drop the data in, and you just keep putting data in that application, and we will make sure that we are provisioned, very similar to App Engine, to handle the load. So there's no pre-thought on Datastore. It's a really wonderful thing to be able to just get started without making any decisions ahead of time, and Datastore will work with you to then scale up your data to whatever the size of your application. Cloud Datastore, fully managed NoSQL service. So it is, again, I try to position it and talk about it as a document store type use case. There's no schema. You drop data in. We do some inference on the data to make it easy to store and make it as performant as possible. But it is different than Cloud SQL. So Cloud SQL is a dedicated resource system where you say, this is my VM, this is my compute. And so you can do whatever you want to that capacity. With Datastore, it's a multi-tenant system, and so when you are using the system, we put certain limitations in place to make sure that all of your queries are fast. So it's really designed to have low latency, fast performance all the time with, again, no forethought. You don't have to worry about schema design. You don't have to worry about creating indexes. We're going to do as much of that as we possibly can automatically for you so that the application will scale once you put data into it. All right, now we're starting to get a little bit more interesting. So now we're starting into more than a terabyte. So if you have more than a terabyte of data, you're generating some interesting amounts of data. And this is where a lot of the talks that we've had today lean to. So when we talk about some of the Spotify use case and some of the other ones, it's all about how are they aggregating lots and lots of data, right? If you're talking about Internet of Things and IoT and sensor data, where do you take all of that sensor data, which is essentially a timestamp and an identifier and a value? Where do you drop all that data in a single place with super high read throughput so that you can then do table scans on it and get some data, get some value out of it later? So this is where Cloud Bigtable is what I'm really excited about for this use case. So 3 different ways that you could think about using Cloud Bigtable. So first of all, at the device level, and again, this could be an IoT device, it could be a device running Brillo or Weave or whatever you happen to be using, and it's pushing telemetry data back to the system. Now, the way that it pushes data back to the system is it pushes the data to PubSub. So every reading is a single message on PubSub. And what's great about PubSub is it's this globally available message queue that allows you to push data to it from anywhere. So that device could literally be it doesn't have to be anywhere near a data center. It could be an individual mobile device or IoT device. It pushes the data back to PubSub for asynchronous processing. Once that message gets into PubSub, it's durable. It's not like running your own message queue software on a VM. It's globally available. And again, Google Site Reliability engineers are making sure that that's always up and running. The other thing that's great about it, and this is a recurring theme, is that you don't have to provision it. You don't have to say, I need 1,000 queries per second of capacity. You can just throw data at it. And as long as your data, as long as the number of requests that you're sending are lower than millions of QPS, right? This is something that we can handle just because all of Google runs on the same infrastructure. So when you're sending messages to PubSub, you're using the same infrastructure that Google uses for all of our asynchronous processing, and you can be confident that the system's not going to fall over. If you need to push us a petabyte of data, you can have very high confidence that we are going to be able to handle that because we have lots of experience in handling that much data, both for our internal applications as well as our other customer applications. So once those messages get into PubSub, how do you process them and get them into Cloud Bigtable? One example, and again, there's many ways to do this, is Dataflow. So you can use Dataflow to then pick up those messages, do any transformations, do any enriching, whatever you want to do, either in a batch or a stream mode, and push that data into Cloud Bigtable. So that's one way to do it. You could do this also with Dataproc. If you have an Apache Spark job that you want to use for streaming, if you have a MapReduce job that you want to use in your Hadoop cluster, or that you've been using on-prem that you want to use in the cloud, both of those provide you the ability to then take that data from PubSub and drop it into Cloud Bigtable. Other ways that you can do this, so if you have a web device or if you have a web application speaking to a VM where you're hosting an application, that VM can speak directly to Cloud Bigtable. So you can write directly from X number of VMs into Cloud Bigtable. Another pattern that we see very commonly is microservice architecture. So if you have a number of mobile apps, and those mobile apps are all speaking back to a microservice or a RESTful endpoint, you often need to collect monitoring data from those. This might be an event. User clicked a song to play in the Spotify use case, or user clicked a link, or user shut the application or opened the application. All of that needs to be recorded. So now, from the microservice, you could push into PubSub and then Dataflow into Bigtable, or you can push directly into Bigtable. It all depends on what your load is and what your architecture wants to look like. What's great about this is that once you get the data into Cloud Bigtable, you have a lot of possibilities. So Cloud Bigtable is our fully managed NoSQL wide column service. Cloud Bigtable and Bigtable internally and the Bigtable white paper spawned much of the Hadoop ecosystem that we have today. And so Cloud Bigtable actually allows you to use the original Cloud Bigtable internal service that much of Google still runs on today. We expose it via an HBase client compatibility. So we provide an HBase client that you can use to integrate with your applications that expect an HBase client. But what's really interesting about Cloud Bigtable, and this is something we spend a lot of time talking about, is while it is we expose it as an HBase client, it is not HBase. And what's interesting about that is it's incredibly low latency random reads and writes. And what this means is that even though it's meant to work in the HBase analytics space, latencies are such that you can actually serve live application data out of this. So you can actually, with like 6 millisecond latencies in and out, you can serve live application data out of here, which is something that most people wouldn't want to do out of self-managed HBase. Very interesting as well, we're seeing a lot of people that are currently managing large HBase and Cassandra clusters. This is an interesting option for them if they want to manage service. If you don't want to roll your own and manage your own clusters, this is a really interesting option for people to move those workloads over and to have them in a fully managed service where Google SREs are looking after your data. The other thing that I do think that I'm also very excited about is a trend that we're seeing externally that we've seen inside Google for many years is this concept of HTAP, which is hybrid transactional analytics processing. And the idea here is that you can keep your application data in the same place that you do your analytics queries. And it doesn't require you to ETL the data into multiple data centers doing transformations. You can leave all the data in a single place and run your applications from it as well as run your analytics queries. So obviously, this greatly simplifies the architecture of an application. And what's great about this is that this is what we've been doing inside of Google for many years. Bigtable, BigQuery, things that allow us to basically have single solutions that allow us to run our applications as well as do our analytics queries. And Cloud Bigtable is a perfect example of how Google's internal use case is starting to manifest itself externally. Two other things to look at. Very excited, a partner, Pythian, recently introduced OpenTSDB support for Cloud Bigtable. So if you are looking for a very well-adopted API for doing time series data, OpenTSDB on top of Cloud Bigtable is a really interesting solution. All right, so the talk is only supposed to go up to petabytes, but we're Google, so we have to talk about exabytes. So if you've gone past exabytes, or if you've gone past petabytes of data and you're approaching towards an exabyte of data, how would you go about doing that? So first question is, how would you actually get that data into Google? So we'll talk a little bit about data ingestion and how we are helping customers get that data from either on-prem or other locations onto Google Cloud storage. So the first one is the transfer service. So we offer Google Cloud Transfer Service, and this is a tool for helping to move around your data. So if you wanted to back up all of your S3 data into a GCS bucket, you can do that and set up a schedule with transfer service. If you want to move your data from a GCS bucket, a Google Cloud Storage bucket that's currently in standard, and after 30 days you want to move data into a GCS bucket which is nearline, then you can do that using transfer service. So we provide that as a tool that allows people to help people move that data around. We're also trying to engage really hard with our partner ecosystem. We really want to enable our partners and help our partners, help our customers get this data into the system. So first one is offline ingest. So we work with Iron Mountain in the US for offline ingest, and Prime Focus abroad for helping people do offline ingest. So if you have petabytes of data or even lots of terabytes of data that you want to get moved into the system, you can put them into a hard drive. And you can ship those to Iron Mountain, and they will upload that data into Google Cloud Storage for you. Same thing outside the United States. The other area that we've really invested in since we announced Nearline last year was the filer and the on-premise file systems. So in the middle of last year, we announced the availability of Nearline. So within Google Cloud Storage, we now have 3 different storage classes. The first one is standard, which is what people have been using to host their static web content and when they're using their data processing pipelines. Durable reduced availability, which in exchange for a slightly lower SLA of availability, you get a price break, which is our second class. And then the third one we introduced last year is Nearline. And Nearline is our warm storage archival solution that allows you to put your data into a GCS bucket with Nearline for basically archival. And as part of that, we've been working with all of our partners in the space to help facilitate that for customers. A lot of these partners have huge enterprise footprints on premise, and they want to be able to back up their files to the cloud. So how do we enable that and make it easy for customers to do that? So working with customers like NetApp, Commvault, EMC, Avere, making sure that when you are running those appliances on-prem or some of them in a cloud appliance, there is the option for you to then push that data into Google Cloud Storage so that you can back it up and, again, have Google's SREs looking after your data to make sure that it is safe and secure and always there when you need it. The last one that I really like to talk about is data pipelines, and we've talked a little bit about this earlier. So great, I've got 500 petabytes of data in Google Cloud Storage. Now what? It's been sitting on-prem. I've never done anything with it. Like, what is the value to me? And most people just want it as optionality in case of a disaster, right? They either need to keep it from a compliance point of view, or they just want to make sure that if something happens, they have a copy of their data. What's so great about this integrated data platform approach is that once you get your data into the system, we can provide lots of interesting tools for you to be able to then take that data and derive value from it. So first one we talked a little bit about earlier is data flow. So if you want to either do batch or streaming, and we've just recently pushed this into Apache as Apache Beam, you can use Dataflow to run large batch or stream processes over your 500 petabytes of data to basically clean it, extract value, transform it, push it into BigQuery, do whatever you need to do with it. And again, fully managed service. If you need 1 petabyte of data or 500 petabytes of data, it's the same code. It's running the same in the same infrastructure, the same set of APIs. So we can scalably go through your data and help you derive value. The second one is Dataproc. And there's another talk just after this one on Dataproc, which I encourage you guys to attend. So Dataproc is really helping customers that are running large on-prem Hadoop installations to be able to easily move those workloads to the cloud. So if you have a MapReduce job that you've been running on-prem, once you push all that data into Google Cloud Storage, you want to be able to run that MapReduce. So Dataproc allows you to just bring that MapReduce into Google Cloud Platform and run that MapReduce over your 500 petabytes of data to get whatever value or extraction data extracted out of that information. And then many of these, if you're doing that information, if you're doing that processing and trying to extract value, you often need a place to put that data. So many times people are running these data flow jobs and data proc jobs and pushing data into BigQuery, into a data warehouse where they can then run their distributed queries. Another thing that I'm very excited about, the direction we're going, which really speaks to the idea that you can put your data anywhere and will help you derive value, is within BigQuery, you can actually do federated queries. So you can do queries against your data that's already in BigQuery, but you can also do joins and queries against your data in GCS. So if you have your data in an Avro or Parquet file in GCS, you can run BigQuery queries against that data and potentially join it with data that you have in BigQuery. But where this becomes really interesting is that we can then expand those federated queries out to Cloud Bigtable and Datastore and all these other areas so that regardless of where your data is, you don't have to ETL it and move it into another solution. And you don't have to ETL it into, and by ETL is extract, transform, and load. You don't have to have a process to move that data into BigQuery. You can just do the queries from BigQuery and query your data inline. So that's where it starts to get really compelling, where wherever your data is in the Google Cloud data platform, you'll be able to then access that data and derive value from it without having to move it around and worry about where it is. One other thing, so in Dataproc, so if you're using HBase, we have HBase connectors, so you use that as an intermediate point in Dataproc. Also connectors for data flow. So making sure that all of these various products work really well against Google Cloud Storage to make it really easy to move your files around. And then no talk about the Google Cloud Platform would be complete without talking about our marketplace solutions. So in our marketplace solutions, we're working with a great bunch of partners so that if one of these managed solutions aren't the right answer for you, then we're working with our partners to make sure that there is something available to you that will hopefully meet your needs. So I've highlighted some here. We've been working with MongoDB so that they're available in the marketplace. So if you need a MongoDB cluster, you can do that. Enterprise DB for if you need Postgres. Currently, we don't offer Postgres in Cloud SQL, and so if you want to spin up a Postgres cluster, you can do so through Enterprise DB. If you're looking to run Cassandra, because maybe your development team has a lot of experience with Cassandra, we offer an easy place for you to take that data and spin up a Cassandra, either single node or cluster, to be able to use that. And same thing with Redis. So if you need Redis for your application, we provide the ability for you to spin up a GCE, Google Compute Engine VM with Redis so you can then immediately start using it in your application. So just to finish up, data is everything. It's at the core of everything we do. We talk about a lot of these applications, and there's amazing things you can do with machine learning. And as you start to build your own models, you're going to need a place to actually store your data. So where do you put your training data? It's going to be in a GCS bucket, or it's going to be in a Bigtable table. And so there has to be a way to get your data into the system so you can start to do all these amazing things with machine learning and other things that we're talking about. And so what we're doing is really trying to make sure that we have that unified data platform so that you can bring your data into Google Cloud Platform. You can put it in the application that makes sense for you so that it's cost effective. It's the application or framework or software that you're accustomed to working with. And then once you do that, we'll make it very easy for you to be able to move it, transform it, and derive value from it. And we want that to all be in one place. We don't want this to be something that you have to think about. As I talked about before, we're always trying to give you optionality. We want you to be able to choose the solution that you think is best for you. And then as you scale up, make it as easy as possible to scale up your application to meet the needs of your users and your business without having to make a bunch of decisions up front. We don't want you to have to provision what you're doing in the future. We don't want you to have foresight into what your company or business or use case is going to look like. We want to make it easy for you to get up and running as quickly as possible and then allow you to scale so that your business can be successful. That's it. Thank you very much.